Hey guys, Mr. McKinney here, just going over the derivative rules. From now on, you will not have to show the long way of finding the derivative unless the problem specifically asks you to use the definition of the derivative. As long as you don't see those words, definition of the derivative, you're going to be allowed to use these derivative rules, which are going to make your life a whole lot easier. So the first rule is the constant rule. If your original function is a constant, then the derivative of that function is 0. So for example, if my original function was f of x equals 7, the derivative would be 0. And if we think about that, f of x equals 7 is a flat line at y equals 7, and the slope, or the derivative, is always 0. It's always flat, so it always has no slope. This next one is the most important part of this video, so put a bunch of stars around this part in your notes, and you guys need to get these 4 rules copied into your notes: the constant, the power, the sum and difference, and these trig rules down at the bottom. But the power rule is the big one for this unit. Most functions, or any polynomial function, can be written in this form: a constant multiplied by x to the power of n. Now, n can be an integer or it can be a fraction, and this rule will still apply. Now, if your original function can be written like this, a constant times x to the power of n, then your derivative is going to be whatever the exponent was, multiplied by that constant out front, and then you drop the exponent by 1. So instead of n, it would be n minus 1. So for example, if my original function was 7x to the 10th, when I do my derivative, so let's say that f of x was 7x to the 10th, the derivative, f prime of x, would be 10, well, let's keep that 7 out front. So 7 times 10 times x to the 10 minus 1 would be 9. So it would be 70 x to the 9th. So if you have a constant and then x to the power of something, just multiply the exponent by the number in front and then drop your exponent by 1. Again, this is the most important one for today. This one shows up over and over and over again, the power rule. All right, the sum and difference rule basically just says that you can add and subtract derivatives. So if your original function is 2 different functions added or subtracted together, you can just add or subtract the derivatives. So sum and difference is easy. This does not work for product or quotients, and we'll get into that in the next set of videos. And the last set of rules has to do with sine and cosine. So if you start with sine, the derivative of sine is cosine. If you start with cosine, the derivative of cosine is negative sine. Just memorize these for now. We'll get into why this works later on in the course, but for now it's easier to just memorize it. The derivative of sine is cosine, and the derivative of cosine is negative sine. So they switch back and forth, but if you start with cosine, the derivative, you need to add in a negative sign. All right, so let's look at using these rules with some examples. All right, so this first example, f of x equals 4x to the 5th minus x plus 9. I'm going to show the short way first, and then I'll explain exactly what I'm doing, but most of you guys will understand the short way. So if this is my original function and I want to find the derivative, f prime of x would be, this first one I'm going to use the power rule. So multiply that number in front. 4 times 5 is 20, and then drop the exponent, so now it's x to the 4th. This is also the power rule. It's like 1 times x to the 1st. So I subtract, and then 1 times 1 is 1, x to the 0 power, which is just 1. And then the derivative of a constant is 0. So my derivative here would be 20x to the 4th minus 1. Anything to the 0 power is 1. All right, now let's back up a little bit and explain piece by piece what I did. So first of all, we have 3 separate functions. Now the sum or difference rule says that since these are added or subtracted, I can just find the derivative of each one and add or subtract those. The derivative of 9 is 0. That was the constant rule. These two are both examples of the power rule. So on the first one, where I started with 4x to the fifth, let's call that g of x, my derivative would have been 4 times 5 times x to the 5 minus 1. So this is my a x to the n. Here's my a n x to the n minus 1. So for those of you guys that like to see every single step, this is how I went from 4x to the fifth to 20x to the fourth. You do not need to show these steps, but that's what was happening. And then same idea here. So if we say that h of x was equal to x, h prime of x, the derivative of x is 1. And again, you can think of that as being 1x to the first power, and then drop it down to x to the 0 power. Or you can think about it as y equals x is the line that goes through here. The derivative is really just asking for the slope of the tangent line. And there is not really a tangent line because it's not curved. So the slope of the tangent line is the slope of the line, and the slope is 1 on this problem, which is where that 1 comes from. Again, you don't need to show any of this stuff. This is just extra explanation. All right. Now, as I mentioned before, there is not a rule that says you can just divide the derivative. So some of you would be tempted to say, okay, take the derivative of the top, take the derivative of the bottom, and you're done. But that is not what you want to do. You do not want to say that this is the derivative of the top and then the derivative of the bottom. What we need to do is rewrite it. So there's a trick in math that says if you have a common denominator, or if you have one denominator, you could split this into 3 separate fractions. So I could rewrite the original problem as 3x to the fourth over 2x squared minus 2x squared over 2x squared minus 1 over 2x squared. Now, each of these still has a fraction, so I need to rewrite it so that it's in my power formula form. Again, I have not taken the derivative yet. This is still the original function. I'm just rewriting it. 3 divided by 2 is 3 halves. X to the fourth over x squared simplifies to be x squared. 2x squared over 2x squared is 1. And then this last term can be rewritten as 1/2 x to the negative 2 power. Now that I've written them so that they're either a constant or in the power formula, now I can apply the derivative rules. So my derivative would be 3 halves times 2 times x to the first. Derivative of a constant is 0. And then here I'm going to do negative 1/2 times negative 2 times x. When I drop it from negative 2, it's going to go down to negative 3. So my final answer for this one, after I simplify it, and I'm done here. I could stop here on the AP exam. But for the multiple choice, it would probably look more like this. 3x, I don't have to write the 0. Negative and a negative turns into a positive. And then I would rewrite, these will cancel out. The x to the negative third, I'm going to write as 1 over x to the positive third. Again, either of those answers, these last 2 lines, either of those is acceptable. This is what you would probably see on the multiple choice exam. All right. If you want to, I'm going to go do some quick practice. So if you want to, hit pause and try this one out for yourself. I'm going to go ahead and work it out. So before I try to find the derivative, I would rewrite it as 3 separate fractions. And then simplify each fraction before I try to take the derivative. So this first one would become 1/3 x to the third. This next one, 3 divided by 3 is 1. This is going to be x to the first divided by x squared is going to be x to the negative 1, or 1 over x, but it's going to be easier to take the derivative if you write it like this. 3's cancel out, and that's going to leave me with just x. So when I take the derivative, 3 times 1/3 cancels out, and I'm going to drop it to x squared. Bring the negative in front, so now it's negative 1. Drop the exponent down to negative 2, and then the derivative of x is just 1. So then I look at my answer choices. These two are pretty similar, but I do need the 1 here at the end. So C is looking pretty good. All right. Here's another example. Just this one has roots. So how do we turn roots into exponents? And if we think back to Algebra 2 or Pre-Cal, basically we can rewrite this problem as 5x to the 1/2 power plus 1/3 x to the -2 power. Anytime you have negative exponents, anytime you have exponents on the bottom, you want to bring them to the top and make them negative. Anytime you have a root, you can rewrite it as an exponent. Now, when you have an exponent that's a fraction, the number on the bottom tells you the root. So if it's a square root, it was a 2. And the number on the top tells you the power. So in this case, it's x to the 1st power, so 1/2 power. If I had, for example, 5 times the cube root of x to the 7th, I could rewrite that as 5x to the 7/3. So that's just a little side note. Okay, so back to this problem. Square root of x can be rewritten as x to the 1/2. X squared on the bottom can be rewritten as x to the -2. So when I take the derivative here, f prime of x, I'm going to do 5 times 1/2, which would be 5/2, and then I'm going to drop the exponent. If I subtract 1 from 1/2, I'm down to -1/2. Over here, I'm going to multiply, so -2 times 1/3 would be -2/3 x to the, make sure you drop it by 1, so -2 goes down to -3. This is technically fine on a multiple choice exam. It would probably be written without negative exponents. So 5 over 2x to the 1/2 minus 2 over 3x to the 3rd. Or you might see it without any fractions. Since the original problem had roots, the answer might have roots in it as well. So 5 over 2 square root of x minus 2 over 3x to the 3rd. Again, this is fine, this is fine, or this is fine. Any of those are acceptable. This is most likely what you would see on the multiple choice portion of the exam. All right, another example, a little bit more complicated. So let's rewrite it first. We don't want to take the derivative until we've gotten rid of fractions, gotten rid of the roots. So I'm going to rewrite this as 2/3. This is really x to the 1/2. So x to the 1/2 over x to the 3rd, you can subtract it. 1/2 minus 3 would be -2.5 or -5/2. And then 4 times the cube root of x would be 4x to the 1/3 power. When I take the derivative, 2/3 times -5/2 times x, and then we're going to drop it, so it's going to be -7/2. And then 4 times 1/3, and we're going to drop this one from 1/3 down to -2/3. Again, technically this is fine. It would probably be simplified. So 2's would cancel out, -5/3 x to the -7/2 plus 4/3 x to the -2/3. Or you might see it as -5 over 3 x to the 7/2 plus 4 over 3 x to the 2/3. Or you might see it with these turned back into roots since the original problem had roots. So -5 over 3 times the square root of x to the 7th plus 4 over 3 times the cube root of x squared. Again, any of these last 4 forms are acceptable, and they might all show up on the multiple choice, so you need to be able to move between them. All right, here's another quick practice. Just find the derivative. This is just another notation for that. The derivative here, you would want to rewrite the original problem as y equals x to the 2/3 power. So the derivative would be 2/3 x to the -1/3 power, which would be d. All right, hope this helped.